The American Society of Mechanical Engineers is a non-profit educational and technical organization of more than 100,000 members. Approximately 85,000 are practicing engineers, and 20,000 are engineering students. ASME has a wide variety of programs: publishing, technical conferences and exhibits, engineering education, and the development of codes and standards, all aimed at serving the profession, the public, industry, and government. At the Society's headquarters in New York, they're talking about a calendar landmark. ASME Codes and Standards had their birth 100 years ago, when the first performance test code was issued. Earl Kemmler is a past vice chairman of ASME's Boiler and Pressure Vessel Committee. Ed Bethel is an expert in the field of elevator inspection. Marilyn Weber is on the staff of the American Nuclear Society. Bill Wollicott is ASME's Assistant Managing Director of Codes and Standards.
We've been talking to each other in this Codes and Standards business for about 100 years now. And our centennial's coming up. We've got to find a way to tell people what we do.
What will they understand when we talk, for instance, about a boiler? And why are they interested in a boiler? Or why are they interested in an elevator, except an elevator takes them up and down and then they don't have to walk up and down the stairs?
Basically, what ASME is doing in elevators is attempting to get uniform and safe elevators in our country.
Well, you were talking a little bit earlier about a fire, when they brought some outside fire companies in.
Yeah.
Let's
They
hear
had
that.
a very large fire.
And as often happens, they had to get help from a neighboring town. When those out-of-town firemen went to hook up their hoses, their couplings wouldn't fit the hydrants. Of course, the blaze got out of control. It was almost as if an old-fashioned bucket brigade would have been more effective. No matter how sophisticated or modern the firefighting equipment, you must connect the hose to a water source.
So we began to understand that just the threads became a very important thing to be standard.
Bill, I think it's important that in citing the various interests that participate in the development of standards and codes, that people in general recognize that among those committees are also consumers at large.
I guess you could call me a consumer at large. Turn me loose in a big hardware store and I'm apt to go berserk. Oh, not that I'm any kind of an expert as a do-it-yourselfer. In fact, if it weren't for standardization given to us by mechanical engineers, these would behave like thumbs, all 10 of them. Now, we all have a pretty good idea of what a mechanical engineer does. He makes things work. Turn, lift, move, and work. But before things can work properly and safely, they have to fit. And for over a century now, that's what the American Society of Mechanical Engineers has been doing in an organized way, making sure that things fit and work. Whether it's a bolt and nut, a new bit for your drill, a new pipe fitting, even if you're the most skilled plumber or carpenter, you work with things that are ready-made to fit and to the most exacting specification. They fit because mechanical engineers take responsibility for developing standards without which, well, early Hollywood took a comic look at what would happen without which. Even to my untrained eye, this structure doesn't seem to be going up according to rhyme or reason, let alone professional standards. I don't think I'd want to audition for a Maxenic comedy, no matter how much some folks might think I qualify for the role. See? Put it together myself, and it isn't falling down. Nothing to it. Before my visit with you is over, we'll be looking at many things. From nuts and bolts to elevators, escalators, boilers, cranes, we won't even be able to cover all of the devices that affect our daily life. The design for these devices and machines have their starting point in common, uniform standards. These engineers and other volunteers will be serving on codes and standards committees. They are here to learn about some of the issues involved, professional ethics, conflict of interest, and legal considerations.
Going back to 1884, when I used the word code, it was with the intent that it was going to be made part of a legal document. The legal document was a contract. So I think that ASME has followed that from 1884. That's the way I understand the use of the term code.
Each of these code writing committees is balanced so that all points of view and all interests can be represented at the table, so that the possibility for one group or another group to inadvertently or purposefully skew or manipulate the system is diminished, because everybody's there keeping an eye on everybody else.
Today, as always, we are faced with the fact that if voluntary standards are to survive in a free society, we must cultivate the science of human relationships and the ability of the code writers of all categories of interest to work together towards goals which are worthy of alerted society.
You need directions for things you build or repair at home. Manufacturers use codes and standards for the things they build. Boilers, elevators and escalators, bolts, valves, engines, pressure measurement. Science and art really do come together here. I don't think it's an accident that one of the founders of modern engineering was an artist who achieved his immortality with brush and palette. Now, even if he hadn't painted the Mona Lisa and the Last Supper, Leonardo da Vinci would have won renown for his startling notebook drawings, blueprints for mechanical marvels almost 500 years before their time. A mind like da Vinci's inevitably would have to tackle the measurement of time. He designed a clock with two separate trains, one for minutes, the other for hours, each complete with escapement, gears, and weights. Leonardo's scaling ladder, elevated and lowered by means of a crank and large-toothed gear, resembles modern firefighting equipment and cranes. This rotating bridge was originally designed as a defense against approaching battalions. By meshing three cogged wheels of different diameters with the same lantern wheel, Leonardo obtained different speeds of rotation, an idea that eventually found its way into the modern automobile. The visionary light that illuminated Renaissance art and science is no less penetrating today. Converting a long length of heavy wire into bolts or screws that hold together everything from a lawnmower to a skyscraper is a process that boasts its own magic.
With the wide variety of fasteners being manufactured today, it's important that the designer, the manufacturer, and the user of fasteners as well have a good, concise set of standards to work to. The American Society of Mechanical Engineers B1 and B18 documents completely define all the characteristics of a hex head cap screw. Dimensional characteristics such as bolt length, thread length, distance across corners, head height, body diameter, and all of the thread information are concisely contained in both of these documents.
Take a bolt and a nut, put them together and they fit. And the reason they fit is because of standards.
The tensile test is a mechanical evaluation of the minimum strength properties built into the bolt by specification. The tensile test is a mechanical evaluation of the minimum strength properties built into the bolt by specification. The tensile test is a mechanical evaluation of the minimum strength properties built into the bolt by specification. The tensile test is a mechanical evaluation of the minimum strength properties built into the bolt by specification. The tensile test is a mechanical evaluation of the minimum strength properties built into the bolt by specification. The tensile test is a mechanical evaluation of the minimum strength properties built into the bolt by specification. The tensile test is a mechanical evaluation of the minimum strength properties built into the bolt by specification. The tensile test is a mechanical evaluation of the minimum strength properties built into the bolt by specification. The tensile test is a mechanical evaluation of the minimum strength properties built into the bolt by specification. The tensile test is a mechanical evaluation of the minimum strength properties built into the bolt by specification. The tensile test is a mechani
You have to know how much weight or stress a fastener can take before it yields. And this stress test of a heavy structural bolt will take it far beyond the performance requirements before it snaps. It took 80 tons of force to break this single 4-pound bolt. In manufacture and design, it meets the ASME standard. Unfortunately, there are no codes or standards that can protect us from human error. Even so, when accidents happen, we have to hope that something man-made will hold.
In New York, witnesses say it felt like an earthquake and sounded like the world was coming to an end. Without warning, pedestrians on 53rd Street were caught in a downpour of rock, glass, and metal as the crane collapsed 43 stories above their heads.
The accident occurred a little before 11 this morning at the nearly completed Continental Illinois Bank building. Workers reportedly were dismantling a 130-foot crane when it collapsed on the roof, smashing into the concrete facing. More than a dozen windows in the building were shattered. Windows in buildings on Madison and 53rd were also broken. Officials didn't know how long the 30-foot section would hang on. After the area had been cleared, construction workers and police were left with the dangerous task of trying to secure a dangling 30-foot section of the crane, being held only by one bolt.
At any given moment around the world, thousands of cranes of every size and description are helping to build and rebuild man's dwellings, office structures, and factories. Among the most spectacular applications of reliable codes and standards, cranes punctuate cityscapes like giant arms flung into the sky. The basic philosophy that guides the development of codes and standards is clear. With staff assistance, working committees keep abreast of every phase of new technology. They don't wait for accidents to happen. Every problem of manufacture and every planned use are under close study all the time. The engineers and other informed volunteers who serve on the committees that write the codes and standards work hard and long to cover every inch of ground.
We've been asked to begin revisions of these crane standards in accordance with the new ASME operating procedures. Right now we're looking at the standards on portal tower and pillar cranes, overhead and gantry cranes, and industrial crane trucks.
In the standard as it presently exists, we've left a great deal of identifying the requirements for the outriggers and service condition for the outriggers to the manufacturer.
Floyd, can you tell me whether it's the lateral spacing between the outriggers, or is it the extension distances that as related to the total height and lift capacity?
I think our action to date hasn't truly reflected all of the service conditions that the outriggers may see.
The chairman and staff member remain to review the minutes of the first meeting of the Crane Code Committee. Over a period of many months, there will be extensive study and many more meetings before a new crane code is hammered out. Mechanical engineering has to do with the generating and harnessing of power, including the everyday power that we kind of take for granted. We seldom think of the tremendous equipment and the complicated controls that lie behind a light switch.
Most of the power in this country comes from either hot water or steam. And that hot water or steam doesn't care where it gets its source of energy, whether it comes from a nuclear plant, whether it comes from coal-fired, gas-fired, or oil-fired.
At this electric generating plant, the energy source is coal, and its job is to fire up huge boilers. The standards to which they are built also require their periodic shutdown for careful inspection. Tubes have to be gone over for pinhole leaks and welded. Insulation is checked. Each procedure assures a margin of safety before the boiler is fired up again and placed back in service.
An interesting thing that very few people in the country today remember that might help the public to understand how boiler codes eventually got written. And it goes way back to the Civil War, when the Mississippi River steamboat Sultana was bringing Union soldiers who had been prisoners of war back home up the Mississippi. The boiler on that boat exploded, and it killed well over 1,400 soldiers. And from that day, people in this country went to work to develop standards to make boilers safe.
There was a time during the 19th century and into this one when horrendous boiler explosions were almost a daily occurrence. Damage was staggering. Many people were killed or injured. ASME got to work on a series of boiler codes which set standards for the construction, maintenance, and testing of boilers. Accidents didn't stop overnight, but as the codes won greater acceptance, the grim statistics descended to the vanishing point. As we became more comfortable with boilers, we could accept some humor on the subject, and the movie makers of the time were inventively eager to oblige. It ain't rubber, that's for sure. If you have one of these around your house, you probably don't pay much attention to it. Carefree, so to speak. Thanks to this little spring-loaded device called a pressure relief valve, the margin for safety is built in. The very first ASME code was for boiler testing, and it goes back to 1884. That's when ASME began organizing balanced committees to develop standards that would be absolutely practical. These publications contain carefully written criteria for all kinds of machinery and testing processes. And they contain language that actually can be written into purchase orders and contracts. Engineers, manufacturers, users, and regulatory bodies have been using these documents down through the years to minimize mistakes, misunderstanding, inefficiency, accident, and maximize reliability, economy, and safety. Several months after the first committee meeting, the work on revising the ASME crane code continues as volunteers review the details and all the issues.
The scopes of both standards need to be bolstered, and we need to identify and standardize a greater area of equipment which is included in these standards, which heretofore have been left to the builder.
Well, the scope of these standards isn't just the design and construction, which I think is a very separate subject from the subject of the qualification of operators of cranes. So I don't think we're talking about just two standards. I think we're looking at the subject of what standards are really needed to cover cranes.
A crane is certainly one of the most conspicuous things mechanical engineers design. I don't imagine you've ever ridden a crane, but there are other things that lift and carry with which you come into personal contact. You depend on elevators to go up and come down like they're supposed to. And even if they get stuck, which isn't very often, they don't fall down. Not anymore. The whole system, including safety mechanisms, adheres to those ever-present ASME standards of design, manufacture, and maintenance.
Elevators are the safest form of transportation we have in the world today. However, anything that's good can always be better. And I think that's what our elevator code is all about.
When you use an escalator, you're confident that it won't do something funny like hurtle you into the lingerie department or suddenly reverse in the middle of taking you up or down. Unless you happen to be around when they're installing an escalator or putting in new parts, you'd need X-ray vision to appreciate what makes those steps travel round and round. The motors, wheels, chains, and gears operate smoothly and almost silently as you think idly about where you've been or where you're going. Moving things around and making things fit. That impulse is built into the human character almost from birth. You're looking at mechanical engineers. Well, I'll bet you some of them will grow up to be real ones. They'd better. For progress depends on minds and hands that will give us new machines and improve on the old ones. If that doesn't happen, things won't continue to fit or stay put or work. It's fun to play with models, but for these grown-ups, it's serious business. What you're looking at are the small-scale prototypes of the working innards of nuclear power plants.
There's one thing that we have to make sure that we tell the public. It's not our decision whether or not a nuclear power plant's going to be built. However, if it is going to be built, we want to make sure that it's built safe. And that's what our nuclear codes and standards are about.
Nothing can be safe unless there are rules to assure that safety. And they have to be clearly written rules that manufacturers can follow and regulatory agencies can enforce. This plant will harness nuclear energy for peaceful purposes. There are ASME codes and standards for the reinforcing bars, as well as the concrete that will encase them. Rigid standards cover the heat exchanger. These same standards require the manufacturer to have a rigid quality assurance program and a third-party inspection agency. If the manufacturer meets all the requirements of the code, he may apply the ASME stamp on his equipment. ASME standards apply to the great turbines and pipes that lead into them. And they apply to the testing of parts that rotate within, as well as to the generators. The result is electricity. All of it has to be done by the book.
We're not a bunch of scientists working in an ivory tower somewhere. Any code that's developed in the ASME system has all of the inputs from the entire society. That is, general interest users, the consumers, if you will. Actually, yes, engineers. For instance, right in this room, there's 4 of us here. You're an engineer, but you're basically a manager rather than a guy working with your hands. I'm an insurance man. I happen to be an engineer, but I am an insurance man. I represent the insurance company interest, the insurance industry's interest. And here's Ed, and he's an enforcement authority, but he is active in the developing of a code. And here's Marilyn over here. She says, I'm purely an administrative type, but she's active in code development. So right in this little room, even though we don't work in little closed rooms like this, we've got 4 separate and distinct interests involved.
And I think it's important that everyone has a say, and that we tell everybody that they can participate.
In other words, it's a consensus system.
Gentlemen, have your attention, please. You all have copies of the agenda. The proposed standard was attached to the minutes of the last meeting for your review.
I cannot understand how we can have a standard that is going to cover all these items and not know when we've met the standard. We don't know if we've met it after design or fabrication, operation, or licensing. How do we know when the requirements have been met when it's one standard?
They felt it was necessary that the operator qualification and the design of cranes be considered together, because sometimes the operator qualifications are a function of the some of the design aspects of the cranes.
Mr. Secretary, would you read the motion, please?
When the give and take of debate culminates in a vote, it's 10-5 for acceptance of the new crane code. But those 5 dissenting votes are not brushed aside. They'll be given another chance for rebuttal and review by the whole committee. And then, finally, there will be a new and revised ASME crane code for public scrutiny and comment. Bear in mind, the mechanical engineers and others involved in the development of codes and standards are not the cop on the beat. They can only write the rules, not enforce them. ASME offers industry and the public some very important guidelines in the name of safety and economy, based on scientific principles and scaled to human needs. And that's the story of ASME codes and standards. I hope we've nailed it down.